Hello, students. Welcome to your video lesson for Chapter 9. In Chapter 9, we're going to be discussing volume. We're going to continue talking about the same three-dimensional solids that we were talking about in Chapter 8. Okay, the same five from the last video. Rectangular prisms, cylinders, rectangular pyramids, cones, and spheres. But in this video, we're going to find the volume of them and talk about the formula for finding volume instead of the formulas for finding the surface area. What you'll notice for the most part is that these formulas are more simple, and they don't have so many pieces that we have to add together. A lot of them, well, in fact, I don't think any of them actually involve any addition. It's just all a bunch of things multiplied together and divided in some different dimensions, things like that, okay? Again, here's the five shapes, and we'll go through each one individually. Now, finding the volume of a three-dimensional figure basically is the idea of finding the total space inside of the figure. How much water could you put inside of that three-dimensional solid, okay? For a rectangular prism, this is probably one of the very first things we ever learned about in terms of volume. Rectangular prism volume is simply the product or multiplication of the three dimensions, length times width times height. Okay, we take those three numbers, we multiply them together, we have the volume. As a general rule, what you will find, particularly for prisms, okay, because we talked in our last video about how there could be different prisms, like maybe one with a triangle on the bottom, right, that goes up, and then a triangle on the top, right? If we have other types of prisms, the general idea for the volume of a prism is the area of the base, or the area of the bottom of it, multiplied by the height. Okay, and so that's why we have here, the area of the base is a rectangle in this case, length times width. That's this length times width, and we multiply that by the height, and we have the volume of the shape, okay? So just keep that in mind as a general rule. If you ever run into, in some other context, finding the volume of a triangular prism or anything like that, it's simply the area of the base, or that shape on the bottom, multiplied by the height. Now that idea also comes into play with cylinders, okay? So cylinders is the same idea. It's the area of the base multiplied by the height. Now, in this case, though, the base is a circle. So the area formula for the base of the cylinder, or the circle, is pi times the radius squared. So that's why our formula for the volume of a cylinder is pi times the radius squared times the height. So, you know, for example, if the radius of this cylinder were 6 inches and the height were, let's say, 10 inches, then the volume would be 3.14 times 6 squared times 10, okay? So 3.14 times 6 squared is 36, times 10 gives us 1,130.4, and that is in inches. Now, when we're dealing in volume, okay, we have to increase our units again, okay? So remember when we talked in Chapter 5 about perimeter, that was just regular units around the shape. Areas and surface areas from our last video were square units. Now in this case, we have cubed units, okay, raised to the third power, because we have three dimensions that are all being multiplied together. So do remember that volume in all of these cases is in cubic or cubed units, inches cubed, meters cubed, feet cubed, and so on, okay? So that's the volume of a cylinder, pi times radius squared times the height, okay? Now when we get to pyramids and cones, you'll notice something somewhat interesting. Pyramids and cones volume are very much related to prisms and cylinders, okay? So for a rectangular pyramid, the volume of a rectangular pyramid is exactly the same formula as the rectangular prism, length times width times height. However, the pyramid gets divided by 3. Okay, the pyramid's volume is 1/3 as much as the rectangular prism's volume. So we just do length times width times height times 3. Now, it's important to note that in this case, we need to see the height all the way from the top all the way to the base at this, and it needs to hit the base at 90 degrees. So what that means is we have to drop it down to essentially the center of the base, okay? So it'll come down like this, hit the center of the base at 90 degrees, right? So that's a 90-degree angle. That right there is the height. It's not down the side of the pyramid. It's straight down the center of the pyramid. That's our H, okay? It has to drop straight down the middle. An alternative formula here is we could do 1/3 if we prefer fractions, times length, times width, times height. These are exactly the same thing, whether multiplying by 1/3 or dividing the whole answer by 3, okay? In this case, if we just do a quick example, if the height here is, let's say, 7 meters and the length on the base is 5 meters and the width is 3 meters, we would simply do this formula, 5 times 3 times 7, and then once we have that answer, we'll divide by 3. Okay, so 5 times 3 is 15, 15 times 7, 15 times 7, 70 plus 35 is 105. That's divided by 3, and we arrive at 35, and in this case, meters cubed. Cubed because it's volume, okay? So again, formula here is length times width times height, making sure the height goes down the center. Then once we have that answer, we divide it by 3. That's our volume, okay? Same thing is true for a cone. A cone is 1/3 as much as a cylinder. So you'll notice that the top of this fraction here is exactly the volume formula for a cylinder. So it's the same formula, pi times radius squared times the height divided by 3, okay? And an alternative formula, of course, is 1/3 times pi times the radius squared times the height, okay? So in this case, all we need to know is the radius length here, and then the height, again, is not the slanted height down the side, right? Remember in our last video, we had S for a slanted height. The height here has to go from the top of the cone straight down to the center of that circular base, okay? And hit at 90 degrees, of course. So if, for example, the height here is 6 and the radius is 4, then we can find the volume by simply doing 3.14 times the radius, which is 4 squared, times 6, all divided by 3. So if I do what I see on the top here, if I do 3.14 times 4 squared, which is 16, times 6, I get 301.44, and that's going to get divided by 3, and my answer is going to be 100.48. 100.48. And I don't have units here. Let's just say it's in feet. Okay. So this then, the volume would be in feet cubed. Cubed units again because it's volume. So cubic units all the time. Now our last formula for volume, the last shape we need to look at is a sphere, the last solid that we have. And you'll notice that this also has a divided by 3 in it in my version, or it has a fraction with a third. So, whoops, and I forgot to change this from surface area. This is supposed to be volume. Volume. Okay, volume. So the volume of a sphere is given by this formula. It looks somewhat similar, particularly the top of this fraction looks somewhat similar to what we saw with surface area, right? The surface area formula, remember, was 4 times pi r squared, because it was 4 times the area of the circle. That was the surface area. Now for the volume, what we do is we take the squared on the radius and raise it to the third, which should make sense, right? Because units on this are now cubed units to the third power. Instead of inches squared, it's inches cubed. So we raise the radius to the third power, and we keep the 4 pi, and then we just divide it by 3. An alternative formula for this that you see most often in textbooks and things is they'll do 4/3 as a fraction times pi times radius cubed. Okay, but any which way you slice it, all you need to know in this case is the radius of the sphere. Let's say the radius in our case is 5 centimeters. I can simply plug that in. Whoops, I'm not going to put pi though. I will do 4 multiplied by, on the top here, 3.14 multiplied by my radius, which is 5 to the third power. And then once I do all of that math, I'm going to divide the answer by 3, and that is going to be my volume. So 4 times 3.14 times 5 to the third, and I get 1,570. Okay, 1,570. That's going to get divided by 3, and I arrive at 523.3, repeating 3333333 centimeters cubed in this case. That is my volume. Okay, so volume is always going to be in cubic units. We now have a formula for each of our different types of three-dimensional solids. If you have any questions about finding the volume of a sphere or a cone or a rectangular pyramid or a cylinder or a rectangular prism, please let me know. Reach out to me. I'd be happy to help. Otherwise, that's all I have for you right now, and we will talk to you soon.